Hi everyone, this is your video for Variables and Patterns 3.3. Make sure that before you continue with this tutorial that you have your 3.3 notes out, ready to fill in, and something to write with. So for this lesson, the first thing we want to look at is our learning target. And our learning target up here at the top is that we are going to create equations using variables with two operations. So that's our main goal. We will once again be working with tables and graphing just to continue to see how all this information connects. The problem we're going to be working with comes directly out of your Variables and Patterns book, problem 3.3, which is found on page 72, if you would also want to reference back for your book. But all the information you need is on the notes in front of you. So the problem straight from your book reads, Liz and Theo want to visit Wild World with their friends. Theo checks if the park offers special prices for groups larger than 3 people. He finds this information on the park's website. So this colorful picture is what is found not only in your book, but is the screenshot off from the website. So we're going to use the fact that regular admission is $21 per person and the special group price is $50 plus $10 per group member or per person who is visiting the park. So part A is to complete a table to show admission price for groups of sizes 4, 8, 12, 16, and 20 people. And we are going to create a table that first is taking into account that every single person is paying regular admission. And the second table is we are going to act as though that group of people is paying the special group price. So what I would like you to do is to try and complete the table on your own. So pause the video, and then once you start it back up, you'll be able to see my answers to the table, and we'll discuss a little bit about how I found those. So go ahead and pause now and fill it in. Alright, let's look at just the first table first. And I apologize, my numbers are pretty big, and I have a typo there, so I apologize about that. So if each person were to pay regular admission, in case the numbers aren't as clear, 4 people would be a total of $84, 8 people, $168, 12 people, $252, 16 people, $336, and lastly 20 people would be a total of $420. If you are unsure of how I got those, for each one of those categories, I took the number of people, so for instance 4 people, and then I multiplied that by the cost per person, so $21. So then for 8 people, I did that there were 8 people going into the park, multiplied that by the cost for each person, 21. And I did that for 12, 16, and 20. Alright, if you already have the second table filled in, great. If you do not, go ahead, pause the video once again, and now make sure that you are paying attention to on the screenshot the special group price where you have $50 plus $10 per group member. And then after you're done pausing the video and attempting it on your own, when you come back, you'll see how I did it. Alright, so for the special group price, I have dollar amounts equal to, for 4 people, $90, 8 people, $130, for 12 people, $170, 16 people, $210, and for 20 people, $250. To find each one of those values, we had to consider the special group rate. So the initial cost into the park is $50, and then it was $10 per person. So if I had 4 people in my group, that would be an extra $40. So I had 50 plus 40, giving me 90. Then for 8 people, I had the initial $50. Then I need to add in $10 per person, and since there were 8 of them, that's $80. So 50 plus 80 gave me the 130. And that pattern continued on for 12, 16, and 20 people. All right, now we're going to continue practicing going from tables, graphs, to equations. So the next step is to do our graphing, but before we can graph, we need to make a list of ordered pairs. And we are going to make each table a separate line, but we are going to put it on the same coordinate grid. So when you pause the video to make your ordered pairs before checking out what I have, it'd be a great time to grab 2 different colors if you have that fairly handy. So go ahead, pause now, make your list of ordered pairs from the table where you paid regular admission, and then make your list of ordered pairs from the table where they paid the group price. Alright, so you can see my list of ordered pairs for each one of the tables. Again, the one thing that you need to remember when you are going from a table into ordered pairs is that the first category in each table, whether it be on the top or the one that comes first if the table is going vertical, that is always going to be your X value. So this top number, like 4, is going to come first in our ordered pair because ordered pairs always go X, Y. And then the bottom category, no matter what it is always going to be your Y value. And that goes the same whether it's the regular or the paid. So those are the 2 groups of ordered pairs. Now we're going to take those 2 groups, and I'm going to use the 2 colors, the blue and the orange, and flip over now to the back side, and we are going to graph these 2 sets. So here's our coordinate grid, and the one thing that you want to remember when you are graphing are some of those key things that you always need. You always want to label your X and your Y axis. I want you to add in a label for what your X axis represents. I want you to add in a label for what your Y axis represents. And I want you to add in a title of something that would summarize what this information is. And one other thing that we are going to add in is a key. And this key is going to show us either the colors that you use or the pattern that you use and what it's going to represent. Whether it's going to be your regular price or the group price. And I need to flip back, so I need to double check my colors. Okay, blue and orange. So my regular is going to be blue. I'm just going to add a little blue there. And my group price then is orange. So those are going to be the 2 colors that I choose when I graph. Now I want you to try and come up with appropriate values to go along the x-axis and the y-axis, and by values I mean numbers that are going to represent each one of those lines. I want you to try it on your own before you take a look at how I graphed it. And remember, even if we chose different numbers or we skip counted by a different amount, that's not a problem. What we're looking for is kind of the general trend or shape of the graph. So see if you can graph it on your own, then come back and see what mine looks like. Alright, so mine is graphed. Hopefully yours looks similar to mine. Again, on the bottom for the x-axis, so right here I'm talking, I decided that every line would be worth 2. You could have gone by something different. And then for the y-axis right here, my initial jump was 80, which is fine to have one that's big, and then after that I skip counted by 40s. So each line is 40 more. And again, you could have a different one, but hopefully what you see is that whatever colors you chose, so for me, the blue, that goes up fairly straight in a line, and then my orange color is a little bit more gradual, but those dots also fall in a line. And one thing that I want you to notice is how things change right there in the circle. So my blue dot, my first blue dot, which stands for the regular admission right there, is actually, that is the only time that the regular admission is cheaper or more reasonable than the group rate, because that dot is lower. Whereas as you continue, then the blue dot is above or higher than the orange, meaning that price is more expensive. So if you were to have 4 people, what you can take away from that, if I zoom that in a little bit, is that 4 people, you would want to pay the regular price, but anything more than 4 people, this graph shows that you would actually want to choose to go with the group rate because you would be paying less to the park and your admission would be cheaper. So that's one way of interpreting the graph that you just made. All right, so let's take what we've done and now turn it into equations. So again, we're looking at these 3 different relationships: tables, graphs, and equations. So 3 ways of writing the same data. All right, so question 1 asks to write an equation to find the price P, so that's the variable we're going to use, when a certain number of people, N, enter the park, paying regular admission per person. So that would be going back to this first table right here. They paid regular admission. And if you look at what we did, we took the number of people that entered the park and we multiplied it by how much the park charged, which was $21. So we're going to do that here. We're going to say that the price, P, was found by doing the number of people going into the park times the cost per person, $21. Now in math, we have something called the commutative property, which means with multiplication I can take these 2 values, flip them around, and I get the same answer. So it would still be just as acceptable to have the equation P equals 21 times N. And oftentimes, when you're multiplying in math, you actually avoid writing the multiplication symbol. So we use the idea of the coefficient that we've been working with, where you squish the number right next to the variable. So I have P equals 21N, which stands for the price is equal to $21 times the number of people who go into the park. So this last equation, although the other 2 that I wrote, they're not incorrect, the one that has the arrow is going to be the one that you're going to see most often, and that form is what we're going to be working on. All right, so question 2 is we need to find an equation for price P when a certain number of people, N, enter the park using the group rate. So let's go back to the front page and take a look at table number 2 and what we did. Well, it was $50, and then we had to add $10 for every person who went in. So we had our $50, and then if it was 4 people, well, 4 times 10 is where the 40 came from. So let's put that into an equation now, where our price is equal to the $50 that gets paid to the park plus $10 times how many people enter the park. So this is an example where we have 2 operations that are happening. We have our plus sign and we have our multiplication sign. So it's a 2 operation equation. And we can do the same thing that we did in the first one, where we change the order and we combine the variable with a coefficient. So it could be P equals 50 plus 10N, so we avoid using the multiplication sign. You could also use the commutative property and say, well, that's the same thing as 10N plus 50. Because just like with multiplication, in addition, we can flip around the two things that are being added, and it doesn't change the final outcome or the value. So one thing that I need you guys to continue to think about is part D, where we put it all together, where how you can use a table, a graph, and an equation to find the cost of an unknown value. So in this case, it's looking for you to find the cost of 18 people, which was not a number that we had to find in our table. So I'm not going to walk through this, but that's what I want you to think about. I need you to answer yourself, do you think that you could use a table, a graph, and or an equation and find how much it would cost 18 people to enter the park? If you can answer that and go back to our learning target where you can create equations using variables with 1 or 2 operations, then you are well on your way to understanding investigation 3.